Our learning target for today is I can graph quadratic functions with its properties or with their properties. So what I mean by properties is that we're going to be labeling the y-intercept, zeros, and vertex of quadratic functions that you're given. So that's the labeling part, knowing how to identify that when you graph. Okay, so one second. Let me just try to make this a little closer. Okay, so we got that learning target in. So now we have this example one. I want to graph this function and I must label all these things. So x squared plus 4x plus 3. The first thing that I always do is the y-intercept because that's the easiest to find. The y-intercept is always the last number in my quadratic function and it's always the constant, which means it's not next to any variable. So let's go ahead and put a dot there at y equals 3 right here on the y-axis. That's my first point on there. So I got one thing out the way. My y-intercept is at y equals 3. At the end of all this, we're going to be labeling. All right, next what I'm going to do is let's go ahead and find the zeros. So the zeros are when I set my function equal to 0, right? Step 1, set my function equal to 0. Step 2, use the box method to factor. And if all else fails, use the quadratic formula. Let's go ahead and use the box method right here. So what I'm looking for are multiples of 3 that add up to give me positive 4. The numbers that work, I believe, are 3 and 1 because 3 only has 3 and 1 as its multiples, and then 3 plus 1 gives me 4. So this works. All right, I'm going to go ahead and factor out my greatest common factors here, so that this factors into x plus 3, x plus 1 equals 0. And according to the zero product property, I could go ahead and solve. So my two zeros are at these two locations at x equals negative 3 and x equals negative 1. Let's go ahead and add that to my graph. Negative 3 and at negative 1. All right, so next up, I got my zeros. Now let's go ahead and find the vertex of my function. So remember, the vertex took on various steps. There were steps into putting the function into vertex form. Step 1, factor out the first term. That's if the first term is not 1, but luckily for this function right here, my first term is 1, so we could go ahead and skip step 1. Step 2, take half of the b term and then square it. So let me go ahead and do that on the side. Half of b, my b term is 4. Half of b is 2, and then squaring it, so 2 times 2 is 4. So then the number that I'm going to be adding and subtracting is going to be 4. And that's step 3 in my vertex form steps. And then plus 3 has to come down as well. All right, the next step is step 4, which is to group the first 3 terms and then factor those first 3 terms. So again, we got to do another box method here to factor. So now what I'm looking for is what multiplies to give me positive 4, but it also adds to give me positive 4. I know 2 times 2 is 4, and then 2 plus 2 is 4, so those work perfectly fine. So then 2x and 2x. Now we're going to pull out the common factors. You notice though when you're doing vertex form, this is always going to give you, these two would always be the same. Just in case if you're wondering, it is a pattern that does happen. Minus 4 plus 3 is just negative 1. Alright, we're almost done with putting this into vertex form. Because there are 2 of these, we're going to square. We are now in vertex form, so now I know my vertex. So remember, the x is always opposite, so this is going to be -2, comma, and then this is just -1. So my vertex is at -2, comma, -1. So that is right here. Oops. So then let's go ahead and start labeling. But first things first, it looks a little like I have a point here. I don't have one over here, right? So what I'm going to do is I'm going to draw my axis of symmetry down through this vertex that I just found. So straight down. This is my axis of symmetry. And then what I'm going to do is, because I know this point, I know that parabolas are symmetric. That's a property of parabolas. I'm going to reflect it across the axis of symmetry. So it's 1, 2 spots over here. So 1, 2. That's how I get this last point. Just so that's nice and, I got an even amount of points on each side. So here's my parabola. Again, your parabola should not look sharp. It should look nice and rounded. So let's start labeling. So this is my y-intercept. This is a 0. This is my 0. This is my vertex. And I don't gotta label that point. That was just a point I reflected to make a nice perfect parabola. So here is the steps. This is all the skills that we learned put together to create this graph. And with this graph, understand what all of these mean. What did we just find? Right, so this is putting all our knowledge together now. Okay, so I definitely wanted to take a look at example 2, but example 2, I want to come back to. Let's go ahead and do example 3, and then we'll do example 2, because example 2 has an interesting thing where its vertex and zeros are the same. So that's why let's skip this right now. Let's go on to example 3 first, and then we'll go back to example 2. Okay, so example 3 says to graph this function. We're going to be labeling again and all of that stuff. So first things first is I notice there's a 2 in front of here. So I know that my vertex form the steps. So I'm going to have to pull that out, right? This is just something I'm noticing. Like, uh-oh, I got to do a little bit extra if I see that. It's just what you want to notice. But remember, so when I'm looking at this, the easiest thing to find is the y-intercept. The y-intercept is always that last term there. It's going to be at y equals 16. But I want you to notice that right here on my graph, I don't have y is 16. My graph stops at 10. So we could use our imagination right here. I mean, ideally, if I gave you a bigger graph, then yes, put it in. But right now, we got to do what we got to do. So I'm going to imagine, let's say that y 16 is right here. All right, there's my y-intercept. Let's just imagine, sorry. That's all I did. I just said, okay, 16's here, and that's my y-intercept. Okay. And again, that's because our graph, you can't see it all. Let's go ahead and now try to find the zeros. So we have this function. Okay, so first things first, that I could do my regular box method here to find my zeros. And first, let me set this equal to 0 because that's the step of finding zeros. I could just go ahead and start putting this in the boxes, but I noticed that 2 is a common factor in all of these. And if I factor out the 2, I could make my box method faster. So basically, if I don't do that, I'm going to have to do more work, because then what I'm looking for is factors of 32 to add up to give me -12. I mean, that's not too bad. But I mean, let's go ahead and already pull out a 2 just to make life easier. So then that's -6x, and then this is going to be +8. See, so now basically what I got to find is the zeros of this function, because I pulled out the 2, and that's not going to affect my zeros. You'll see why in a second. So let's go ahead and do the box method. I'll do it right here. So we're just doing it for this one, x squared and then 8. So what I'm looking for is what multiplies to give me 8 but adds to give me -6. So I know that -4 times -2 is +8, and I know that -4 plus -2 is -6. So those end up working. So let's go ahead and pull out our common factors. All right. So then this becomes 2 parentheses x minus 4 parentheses x minus 2 equals 0. Now, according to the zero product property, we could set each of these factors equal to 0 to solve. So 2 equals 0 does not make any sense, so we could cross that off. This right here gives me x equals positive 4 and x equals positive 2. So my zeros are at x equals 4 and x equals 2. Again, if you didn't factor out the 2 and you did the box method, you would still end up with the same zeros, so that's fine. All right, and then let's go ahead and move on to the steps of finding the vertex. And I apologize, but let me make an extra space for finding the vertex right here. All right, so the steps for finding the vertex. So step 1 is we got to factor out the first term's coefficient. By the way, though, before we start that process, let's go ahead and add in my zeros here into my graph already, so I don't forget about them. Okay, so I just added my zeros. Now let's find the vertex. Step 1 says to factor out the first term. Let me just rewrite my function, and then we'll factor out. So step 1 says factor out the first term. It's 8. Okay. Step 2 says to take half of the b term and then square it. So half of negative 6 is negative 3. All squared is going to give me 9. So the number that I'm going to add and subtract is going to be 9. Let me do that down here just so you can see. It's going to get long. The 2 stays out. So again, I've usually been using the brackets, right? So it's going to be x squared minus 6x plus 9 minus 9. Then we have that plus 8. And then I did brackets, just so that I'm consistent with what I did in the notes. Okay, so next, the next step is to group the first 3 terms and to factor those first 3 terms. So then we're going to have to use box method again. Let me do it right here. You should be able to see this. So it's going to be x squared and then positive 9. So what multiplies to give me positive 9, but adds to give me negative 6. Negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 gives me negative 6. So negative 3 ends up working. So let's go ahead and factor. And then this one is x, and then 3 as well. So sorry, that's a 3 right there. That's x minus 3 on top, and then x minus 3 at the bottom. Oops. X minus 3 on top and x minus 3 right here. Alright, so this stuff inside the parentheses is going to become x minus 3, x minus 3. Minus 9 plus 8 is negative 1. Now let me close my bracket. So now what we got to do is x minus 3 and x minus 3 is going to become squared. Lastly, now the last step is to put the 2 back in. We got to factor, not distribute the 2 back in. So then that's going to be 2x minus 3 squared minus 2. Now we're in vertex form. So now we could be able to find the vertex. Remember the x is always opposite. So it says minus 3. It's going to be positive 3. Now this is just minus 2. So my vertex is at 3, negative 2. Great, so we got our vertex. Let's go ahead and put all that information in here. So it's at 3, negative 2. Good, so now I'm going to go ahead and just to complete my graph, do my axis of symmetry. And then imagining that this was 16, there's my next point. I just reflected it. And then I'm going to try my best to draw this parabola. Oops, doesn't really hit that point. But you know, just try. Let's just say it's right here. There you go. Okay, now we got a label. So this is my vertex. This is my 0, and my y-intercept. So remember, you got to label everything to demonstrate to me that you understand, right? How we put all the skills together into this graph. Let's do example 4, and then we'll go back to example 3. Okay, so example 4 is interesting because there's in front of the x squared, there's a negative 2. So that means because my a term is negative, I know that the parabola is going to be facing downward. So let's go ahead and try to figure out this. So step 1, the y-intercept is always the easiest thing to take a look at. So at y equals negative 2. And then, so that's going to be right here, my y-intercept. It's my y-intercept. It's the easiest to find from right here. All right, the next thing that I want to find is my zeros. In order to find my zeros, remember I should be setting my function equal to 0. Because I noticed, because I noticed that 2 is a common factor in all of these, what I'm going to do is I'm going to factor out the negative 2. Just because there's a negative right in front of here, so I'm going to pull out the negative 2. So x squared. So because I pulled out a negative, this sign is going to be minus and then 2x. And then this is going to be plus 1. And you could double check it by distributing this back in, and you should get your original. Just remember, if you're pulling out a negative, all the signs on the inside switch. Alright, so now what I'm going to do is use the box method to find the zeros of this. It's going to be x squared and positive 1. The two numbers that multiply to give me 1, but add to give me negative 2, I believe is negative 1 and negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 gives me the negative 2 right here. So those work. So I'm going to go ahead and pull out the common factors here. Oops. So this is just going to be x minus 1 and x minus 1 equals 0. So then it looks like I'm only going to get 1, 0, right? According to the zero product property, I'm going to set each of these equal to 0. So I'm going to get x equals 1. And then I also get x equals 1 right here. So this is a repeated 0. Negative 2 equals 0 doesn't make any sense, so we're going to cross that out. So we only get 1, 0 at x equals 1. So let's go ahead and put in that 0. Alright, now our next step is to find the vertex of this function. So remember the steps to finding a vertex. And let's go ahead and do this down here with more space. So step 1 to putting a quadratic function into vertex 4 is to factor out the first term. The first term is negative 2. So I'm going to factor out that negative 2. When I do that, make sure that all your signs switch. By the way, I pulled out negative 2. This should turn to a 2. And then plus 1. See how my sign switched? Because I pulled out a negative. Alright, next up is we're going to take half of the b term. This is my b term, and we're going to square it. So half of negative 2 is negative 1. Negative 1 all squared, that's negative 1 times negative 1, is going to give me just positive 1, because negative 1 times negative 1 is positive 1. I'm putting my brackets here just to be consistent. So then the number that we're adding and subtracting is just positive 1. And then we've got to bring down this plus 1 that's over here. Next step in our finding vertex process is to group the first 3 terms. And then what you're going to do is factor those first 3 terms. And it's what's great here though is I already did this factor up here, right? Coincidentally, the zeros gave me the same thing. So, I mean, you could redo the box right here if you want to, but it's already up here. We already did that. See? So, this actually factors into x minus 1 times x minus 1. And then minus 1 plus 1 is 0. So I put plus 0. All right, next up, x minus 1 times x minus 1 is x minus 1 squared plus 0. Next step is to distribute the negative 2 back in so that we are formally back into our vertex form. Negative 2 times 0 is just 0. So here we are, we're in vertex form. So my vertex is going to be, remember this is opposite, positive 1, comma 0, which is coincidentally where my 0 is at. Is that 1, comma 0? That's where my parabola intersects the x-axis. So this one's an interesting case here. The zeros are the same as my vertex location. So basically, what do we do from here? So first, let me draw my axis of symmetry. And I want to mention to you that you need at least 3 points to graph your quadratic function. So in order to get the 3 points, what I'm going to do is I'm going to reflect this point over, reflect it across the axis of symmetry. So I go ahead and I do that, and I sketch my parabola. Again, it's going down because my a term, the a term right here is negative. So I know that the parabola is going down. The last thing I want to do is to label everything. So this is my vertex and my 0. And this right here is my y-intercept. And that's pretty much it. And this we don't have to label. That's just the point I reflected. And there you go. So that is example 4. Feel free to pause this and take a look at how we did that. All right. So let's go back to that example 2 that we skipped. All right, so we're going to be graphing this and labeling. All right, so the first thing, as I mentioned, is the y-intercept. It's at y equals 27. Y equals 27 goes off my graph, but like I said, let's just do what we can. Let's just say this is 27. That's my y-intercept, okay? Okay, next up, let's go ahead and find the zeros of my function. So the first step in order to find the zeros of my function is to set my function equal to 0. The next step is we do the box method. But before I do the box method, what I'm going to do is I'm going to factor out a 3 because I noticed that 3 is a common factor, and that's going to make the box method much easier. So that's all I did. I factored out a 3. And what goes inside, basically, if you divide everything by 3, 3 divided by 3 is 1. Negative 18 divided by 3 is negative 6. 27 divided by 3 is 9. So that's how I get the numbers on the inside. Now all we got to do is use box method for the inside part here. It's going to be x squared, 9. What we're looking for is what multiplies to give me 9 but adds to give me negative 6. The two numbers that work are negative 3 and negative 3. Because negative 3 times negative 3 is 9, and negative 3 plus negative 3 is negative 6. So those work. We pull out our common factors here. So we get x minus 3 and x minus 3. So this one also coincidentally has 1 0 because I'm going to get a repeated 0. According to the zero product property, we set each of these equal to 0, and then we solve. Because this right here is a repeated 0, it's just going to be at x equals 3. 3 equals 0 doesn't make any sense. We cross that out. So we only get 1 0 at x equals 3. Okay, next up, we're going to go ahead and let's put our point there at x equals 3. That's going to be my 0. Now we got to find our vertex. So we got to refresh our steps on the vertex process. And see where's a nice place to, probably right here because I have more space. So let me just rewrite my function. So the steps to putting the quadratic function into vertex form is to factor out the first term, which is similar to what I did before because I noticed I can do that and it made finding zeros easier. I'm going to put a bracket here. Okay, and then the next step was we're going to take half of the b term and then square it, and then we're going to add and subtract that number. So half of negative 6 squared. Half of negative 6 is negative 3. Negative 3 all squared is 9. So the number that we're adding and subtracting is 9. We're going to plus 9, minus 9, and don't forget about this plus 9. The next step in our vertex process is to group the first 3 terms. Then you're going to factor those first 3 terms. And what's nice is, well, coincidentally, I already done that. I mean, it's not always going to be like that, by the way. But coincidentally, this was already factored up here. So I don't have to redo another box. I already know that it's x minus 3 times x minus 3. And then minus 9 plus 9 is just plus 0. So then we have 3 x minus 3 squared plus 0. Now the last step is to factor the 3, to distribute the 3 back in to get this. So this is my vertex form. So remember, the x is always opposite, so it's going to be positive 3, comma 0. That's going to be my vertex. And this one's also similar to example 4 because the vertex is the same as my 0 location. And that's all the information I have. This is all the information I have, so we're going to work with it. So I have my y-intercept, I have my 0, and my vertex right here. So that's my 0 / vertex. I only have one 0. There's the y-intercept. So let's go ahead and draw, because we need 3 points to make a quadratic parabola, right? What I'm going to do is I'm going to reflect this point over across the axis of symmetry. And it would be nice if this point was more exact, right? If my graph did go up to 27, but it doesn't, so it's fine. So I know it goes to the left 1, 2 units, so I'm going to go to the left on this side 1, 2 units. It's symmetrical, so this should be fine. All right, so let's go ahead and create this parabola. To the best of your ability, you want to make sure it looks U-shaped, not sharp or anything like that. This could have been done better, but that's why I got erasers. Just make sure I have all the work shown for you. I also want to mention something that example 1 was the most basic of the process. The other examples, because my A term is not 1, right? You got to factor out the first term. It gets a little more complex, but it is something that you can do, right? And then we're going to talk about example 5 some other time, but example 3 here had 2 zeros. Example 4 right here was upside down because my A term was negative. And here's the whole process that we've done. All right, so you're going to be getting a graph soon. You'll be graphing these as well. All right, good luck.